So in this video, we will solve this question I have on the screen, which says that suppose f prime of 2 equals 3. What is the limit of f of x minus 2 over root 2, over root x minus root 2 as x approaches 2? So what will be this limit? So that's what we are looking for. So let's look at this general formula, which says for the first derivative of a certain value a should be equal to the limit as x approaches a for f of x minus f of a all over x minus a. Okay, so this is the general formula. Okay, so with this formula, we've been given that what f prime of 2 equals what? 3. Okay, so if f prime of 2 equals 3, I can see that f prime of 2, which is equal to the limit as x approaches 2 for f of x minus f of 2 all over x minus 2 equals 3. So this is what this value here means. Okay, since you know this, let's find this limit. Okay, so we've been given that the limit as x approaches 2 for f of x minus f of 2 all over root of x minus root of what? 2. So this is what we have. Okay, so the best thing to do here is to multiply by what the conjugate of what the denominator. Since when we put the value of 2 here, we have what? A certain number about 0, and this will be indeterminate. Okay, so for that matter, we have to simplify this. So you can simplify this to become, so that will be the limit as x approaches 2 for f of x minus f of 2 all over root of x minus root of 2. So I'm multiplying by the conjugate of this, so that will be times root of x plus root of 2 all over root of x plus root of 2. Okay, so let's focus on the denominator. So let's multiply this value here by this. So let me do that at the top here. So I have root of x into bracket root of x plus root 2, okay, minus root of 2 into bracket root of x plus root 2. Okay, so let's do this. So I have x plus root of 2x and then minus root of 2x minus 2. So this and this will cancel out. At the end, I'll have what? X minus 2. So that tells me that the denominator will now be what? X minus 2. So now let's continue. So now I now have my limit as x approaches 2 to be f of x minus f of 2 all over x minus 2 times root of x plus root of 2. So this is what I have now. So now let's go back to the beginning. Okay, let's compare what we have here, okay, to the to this value. Okay, so you see that this value here, f of x minus f of 2 over x minus 2 here is the same as what? This value here. Okay, and it is said to be equal to what? 3. So which means that I can represent the whole of this with what? 3. So that's what that means. So from there I can see that the limit as x, approaches 2 will be equal to what? 3 times the root of x plus root of 2. Okay, so with this I can evaluate this limit because it is not in a quotient form, so it's very easy to evaluate it. So I just put in the value of 2 here. So now I have 3 times root of 2 plus root of 2. So this will be equal to 3 times 2 root of 2, which is equal to 6 root 2. So that will be the answer for this question. So with this question, you'll be asked to find the limit as h approaches 0 for f of x plus h minus f of x all on the h, when f of x is given to be what? 4x squared minus x. So we have this here. So that's the limit as h approaches 0 for f of x plus h minus f of x all over h. Okay, where f of x is given to be 4x squared minus x. Okay, so now I know my f of x. So how am I going to get f of what? X plus h. You simply take this function and then you put x plus h wherever you see x. So I have my f of x plus h to be equal to 4 into bracket x plus h squared minus x plus h. Okay, so this is what I have now. So now you can put this value here and then this value what in this equation. So this value goes for this and then this also goes for this. So now I have the limit as h approaches 0 to be 4 into bracket x plus h squared minus x plus h. Okay, so all this in one bracket minus this f of x, which is what? 4x squared minus x. Okay, so this is what I have, all divided by h. Okay, so from here, for this to be easy for us, okay, let's simplify what we have on top. So the limit as h approaches 0, so that will be 4. This will be, I'm expanding this bracket, so that will be x squared plus 2xh plus h squared. Okay, I get close, minus x plus h. Okay, so I've expanded the numerator, so all minus 4x squared minus x. Okay, all over h. Okay, so let's continue and then simplify it. Okay, so I have my limit as h approaches 0. So let's finish the expansion. So I have 4 times x squared, that will be 4x squared plus 4 times 2x h, that will be 8xh plus 4 times h cubed, that will be 4h squared. Okay, minus x minus h. all this minus 4x squared plus x, all divided by h here. Okay, so let's continue. So we have the limit as h approaches 0. So let's cancel out. So I can take out this and then this. And then so I can take out minus x and then this. So at the end I have 8x h plus 4h squared minus h all over h. So from here we can cancel out h. So the limit as h approaches 0 will be 8x plus 4h minus 1. Okay, so now we said h is what? Approaching 0. So you can put 0 here. So when you put 0 here, I have 8x plus 4 into bracket 0 minus 1. So that will at the end give me 8x minus 1 to be my limit. So that's the answer for this question also. Okay, so this is the next question that we'll be looking at. So you have to find the limit as x approaches to 1 over x minus 2 minus 4 over x squared minus 4. Okay, so there are two ways to do this. That's you can use the L'Hopital's rule, or then you can use the transformation approach. So first of all, I'll use the L'Hopital's rule, then later on I'll use the transformation approach to explain it also. So for the L'Hopital's rule, you can find the LCM of this. That will be x minus 2 and then x squared minus 4. So this will give me 1 times x squared minus 4 into bracket x minus 2. So I now have the function to be the limit as x approaches 2. Okay, so now operating this as this. Okay, so now that you have it in the fraction form, you can apply the L'Hopital's rule. So let's expand the brackets. So now I have the limit as x approaches 2 to be x squared minus 4 minus 4x plus 8 all over. Let's expand what you have down here. So that will be x into bracket x squared minus 4 minus 2 into bracket x squared minus what? 4. So this will be the limit as x approaches 2. So that will be x squared minus 4 minus 4x plus 8. So let's keep expanding. So that will be x to the power 3 minus 4x minus 2x squared plus 8. Okay, so this is what I have now. Okay, so now from here we can apply the L'Hopital's rule. So we can differentiate the numerator and the denominator. So the limit as x approaches 2 will be the derivative of x squared will be 2x minus the derivative of 4, which is 0, and the derivative of 4x, which is what? 4, plus the derivative of 8, which is 0. So all divided by the derivative of x cubed, which will be 3x squared, minus the derivative of what? Minus 4x, which is what? Minus 4, and then minus the derivative of 2x squared, which is what? 4x, and then the derivative of 8, which is what? 0. Okay, so from here, if you have to put in the value of 2, you still get 0 on 0, which is what? Indeterminate. So for that matter, we still have to differentiate to have the simplified form. So I have the limit as x approaches 2 to be 2x minus 4 all over 3x squared minus 4 minus 4x. So to differentiate this, I'll have the derivative of 2x will be 2, and then the derivative of 4 will be what? 0. So all over the derivative of what? 3x squared will be 6x minus the derivative of 4, which is 0, minus the derivative of what? Minus 4x, which will be what? 4. So this will at the end give me the limit as x approaches 2 to be equal to what? 2 over 6x minus 4. So from here I can put in the value of 2. So that will be 2 over 6 into bracket 2 minus 4. That will give me 2 over 12 minus 4, which is equal to 2 over 8. That will be 2 over 8, which will give me 1 over 4. So this will be my answer. Okay, so this time around we'll be using the transformation method to solve for this question. So I have the limit as x approaches 2 for 1 over x minus 2 minus 4 over x squared minus 4. So what I'm going to do is that I'm going to rewrite this. Okay, this machine that I have here, that's x squared minus 4. This should give me x minus 2 x plus 2. That's difference of what? 2 squared. So that will be the limit as x approaches 2 now becomes 1 over x minus 2 minus 4 over x minus 2 and then x plus 2. So now 1 over x minus 2 is common to what? Both sides. So I'm going to factor it out. So I had the limit as x approaches 2 to be 1 over x minus 2 into bracket 1 minus 4 over x plus 2. So from here, I'm going to simplify what you have in the bracket here. So that's 1 minus 4 over x plus 2, all divided by x plus 2. So this will give me x plus 2 minus 4. So I can write this in place of this here. So I had the limit as x approaches 2 to be 1 over x minus 2 into bracket x plus 2 minus 4 all over x plus 2. Okay, so from here I'll move and then simplify it. So that will be the limit as x approaches 2 be 1 over x minus 2 into bracket. This 2 minus 4 give me minus 2, so I have x minus 2 all over x plus 2. So from here this can cancel out this. So at the end I have to be the limit as x approaches 2 will now become 1 over x plus 2. So from here I can put in the 2 to get my limit. So the limit will now be equal to 1 over 2 plus 2, which will be equal to 1 over 4.